right, y'all. So this is 5.2. So what we're going to do today is we're going to work on changing forms between exponential and logs. So let's do a little bit of background here. So definition for exponential and log. So when we did exponential graphing in the last unit, we said y equals e to the x. And just kind of a little bit of background here. So I can make this e any number. I can say 5 to the x, for example. And when I do that, this value of 5 becomes my base. And this x is up here, and this becomes my exponent. And so terminology is going to be super important because when we say the base of, we need to be able to recognize what this base is. So we have a base of 5. The exponent here is x, and this is always going to equal an answer, some sort of solution. We don't know what that looks like, okay? So our format that we're going to use when we have an exponential is going to be b to the x equals answer. And b is the base and x is the exponent, okay? So if we take this and we move it over into log, what we would have is log base b. So this b and this b are the same. So log base b of my answer, so I'm going to use a, this value of a right here is this a for answer, and this is going to equal x, and x is my exponent. So basically what we can say, and that's what this is, generally speaking, a logarithm equals an exponent. So let's look at this. If this is what I have, b to the x equals an answer, and I have this logarithm over here and it equals x, well, x is my exponent. And so it's important because we're going to be going back and forth between these two formats. And my arrow here is a little goobered up, but basically what we're saying is that we can go back and forth between an exponent and a log. All right. So this arrow trick for switching forms, I like to call this the cloud or the popcorn method, is if I have something that is, I'll go back up here. So 5 to the x equals 25. When we do this, we know that we have to say that this is my base. So if I write this, I would say log of base 5. So log base 5 of my answer, so of 25 equals x. All right, so this is how these two go together. And this is why I call this my popcorn method. Because what happens is I say 5 to the x equals 25. And it kind of looks like this popcorn kernel, right? So 5 to the x equals 25. So when we're going from exponential to base, if I say we're going to popcorn it, that's what I'm talking about, okay? So if I want to go and fill out this chart here, going from exponential to log, I'm going to start with log. My base here is the base of my exponent, so log base 5 of my answer equals my exponent. All right, so don't get jammed up if you see something that's a fraction or a negative, because this is saying the same thing, right? This is saying log base 10, this is still my base, of my answer, well, my answer right here is a fraction, equals -2. All right, now, little note, let's put a note over here, negative exponent means we move this, so this means it's coming from the denominator. So when we see this negative exponent, this is like saying 10 to the -2, right? So this means it's going into the denominator, would be 1 over 100. So that's where this comes from. The -2 tells you that it moves down into the denominator. Okay, so if we look at this next one, we're going to say log of base e to the square root of e equals 1/2. All right, now this is a special case. So if you remember, whenever we have log base e, this is the same as ln. And you're going to see I write it with this cursive n. I don't know why. I've always done it that way. So ln and this ln are the same. So you'll never write it this way. you'll never write log base e. You're going to write ln, and there's no e. So the way we would write this is going to be ln of the square root of e equals 1/2. And this is how we would write that when we have a natural log, an ln. Okay, so now I'm going to go backwards. So if I'm going backwards, remember this ln is the same as saying log base e, or ln of e. So here we would say e, remember I'm popcorning this, e to the n equals q. So e to the n equals q. All right, here I have a base of 25 to the 1/2 equals 5. So 25 to the 1/2 equals 5. Now, just in case you've forgotten this, any exponent that is rational, so that is a fraction, so exponent of 1/2 is the same as a square root. So if we think about this, what we're really saying here is the square root of 25 equals 5, and that we know that's true. All right. Now, this next one looks a little funky because I don't have a number here. So if you remember, so here's another one that we have to know. So if we have log with no base here, this is the same as log base 10. And that is what we have on our calculator here. So on our calculator we have log, well this is log base 10, and we have ln. So this is log base e. Now we don't see this log base 10, okay? So if I have this one, if I popcorn this, I'm going to say 10 to the 2 equals 100 because I'm using this implied 10 that's right here. Okay, so we talked about a couple of these that are our important ones, and that's what this is. So our common log is our log of, it's just log, and this is understood that we have this log base 10. So like I said, we don't write this, but it's log base 10. And this is the log button on your calc. Okay, now our natural log is the one that's ln, and this is the same as log base e, right? Again, we don't use this, and this is an understood base of e. Okay? All right, so let's flip this over. So what this is saying here is remember that a logarithm equals an exponent. And we said that on the other page, but it's so important we're going to say it again. So log base answer equals exponent, and base to the exponent equals the answer. So this is the same thing. It's just rewritten here so you don't have to flip it back and forth. So what this says is we're going to evaluate the following. So if I have this, this is like saying log base of an answer equals the exponent. So I'm just going to make this an x right now, just because this is our exponent. So if I popcorn this, I have 2 to the x equals 2. Now, what we know here is that there's no exponent on this, but we have this implied 1. Now, because we have the same base, we're just going to say that x equals 1, so my exponent here equals 1. Now, here's a shortcut. If you have a base and an answer that's the same, it always equals 1. So, log of the base that equals the base, this is always going to equal 1. All right, so what we see here is log base 2 of 2. We know this is always going to be equal to 1. Okay, so if I had, for example, log base 6 of 6, we would say that that equals 1. Okay, so this one, if I add an x on here, I'm going to say 2 to the x equals 8. 2 to the x equals 8. So I can look at this and I just know 2 cubed, 2 times 2 times 2 equals 8. So I know that the answer to this is going to be 3. But let's say this is a harder one. The goal here is that we want to turn these bases into the same number. So if I have 2 to the x and this equals, I'm going to take this 8 and I'm going to make it base of 2. And I say 2, 4, 8, so 2 cubed. I can cancel out my bases and I can just say x equals 3. I'm just taking my exponent equal my exponent, and my answer here would be just 3. Okay, so that's kind of where we're going as these get harder. We're going to want to change our answer or change our exponent so that we end up with the same base. Okay, so I have no base here, so it's an implied base. So I'm going to have 10 to the x equals 100. What do I do to go from 10 to a 100? The solution here is going to be 2. My exponent here is 2. All right, so I look at this last one, and I have 5 to the x equals 1 over 25. Now, remember, when we have a negative exponent, it means it moves. So this is the same as saying 5 to the x equals 25 to the negative 1. All right, so negative 1 means the exponent moves, it moves to the denominator. Now, if I want to give this the same base, I'm going to say 5 to the x equals 5 squared, so 5 squared is 25, times negative 1. So what we know here is that my solution is going to be negative 2, because x equals 2 times negative 1, which is negative 2. All right, now there are a couple of cheats that you just need to know. So x to the 0, we know anything to the 0 power equals 1. All right, and then the other one that we know is ln e to the x equals x. So ln and e they don't really cancel each other out, but we can say that they cancel each other out. So what happens when we do this is it's almost like this goes away and my solution becomes just my answer. Okay, so if I have this, x to the 0 equals 1, then that means log of any base that equals 1 is going to be 0. So ln of 1, this is the same as saying e to the x power equals 1. Well, anything that's going to give me 1, here x has to be equal to 0. So these are just a couple of log and exponential powers rules that you just kind of have to memorize. So same thing here. 4 to the what power is going to be 1? Well, that's going to happen when x equals 0. Okay, here I have an ln and an e, so the ln and e cancel each other out, so the answer here is 4. This is an implied 1, so my answer here is 1. And this is the same as saying ln e to the negative 2 to move it in the denominator, so my answer here is just going to be negative 2. So again, this is just one that you're going to have to be able to just see and recognize. So here are a whole bunch of examples of all of these. And what I'm going to do is I'm going to work a couple of these, and then I want you to go back and work some of these. Okay? Let me do number 8. So number 8 is the same as saying ln e to the 1/2. Remember, whenever we have a square root, the square root tells us that it's a 1/2 power. So because I have an ln and an e, they cancel each other out. So this answer to this is just 1/2. Okay. Now, one of the things we didn't talk about is if I have ln e to the x, we said that the ln and the e cancel each other out. Well, I can write this another way too. I can say e to the ln x, and this is the same thing. The e and the ln cancel each other out, and so the answer to this would just be x. So whether it's ln e or e to the ln, all it does is it equals whatever that exponent is. Okay? So if we go back down to number 9 here, I have e to the log 3. So because this base is a 3 and this base is a 3, they cancel each other out, and my answer here is just 5. All right, here's another one. E to the ln. E to the ln, they cancel each other out, so my answer here is just 7. Okay, let me do a couple more. So I'll do this one, number 12. So here, if I popcorn this out, I would say 7 to what power equals 49? Well, 7 to what power equals 49 is going to be 2. All right, and then let me do number 16 here. I would say 5 to what power equals 125? So 5 to what power equals 1 over 125? So I'm going to rewrite this because the goal is to have the same base. So 5 to what power equals 5 to the negative 3. So 5 cubed is 125, but because that 125 is in the denominator, we make it a negative 3. So the value here is negative 3. Okay, I'm going to pause the video, and I want you to fill out the rest of these and then come back and check your answers. Okay, I did these in another color. As I was going through this, I think the only one that was a little tricky was this one. And remember, whenever the answer is 1, this is like saying base 10 to what power equals 1. And the only thing that's going to give you a 1 here is when x equals 0. That's why this is 0. Okay? If you struggle with any of the rest of these, make sure you come and see me. Okay? All right. So now we're going to go into log properties, and this is just like a puzzle. So I'm going to give you these properties, and then we're just going to rearrange these and work it kind of like a puzzle. So the first one is if I'm adding. If I'm adding 2 logs with the same base. All right, so it would look like this. Let's just say, and remember, log and ln are the same thing. They just have different bases. So I'm going to write this as ln just because it's easier. So if I say ln of a plus ln of b, this is going to be the same as ln of ab. So I take 2 things that I'm adding, and when I put them together, they're multiplied. So adding with the same base, it becomes multiplication. All right, so the next one we're going to do is subtraction. So subtraction with the same base, so it would be ln of a minus ln of b. And I bet you can guess what this is, because when we did this with exponents, this becomes division. So it's ln of a over b. Now, this is super important that you see that I only have one ln. This is not the same as ln of a over ln of b. This is going to give you the wrong answer. All right, so make sure you see that we're going to do the operation that's inside here first. And then the next thing that we're going to have is what happens when we have a power. And this one is a little odd. So if I had something that looked like this, ln of a to the b, what happens is we now take this exponent that's up here and we're going to move it up front. So the solution to this is going to be b ln of a. So we take the exponent, we move it up front, and we multiply it through. Okay? Now, one thing that is super important is we do not use the distributive property with logarithms. So if I have log of a plus b, this is not log a plus log b. Okay? So super important. Make sure you see this. It's not log a plus log b. All right. So what we're going to do here, we're going to evaluate using log properties. So if I look at this, the first thing I see is I have this power of 4. So that is this rule 3 up here, which is a power. So I'm going to say 4 log base 2 of 8. Okay, so log base 2 of 8 is going to give me some x. Well, I'm going to go in right now and I'm going to evaluate just this part of it. So this is saying 2, if I popcorn this out, so 2 to the x equals 8. So that means this is 3. 2 cubed gives me 8. So if I go back up here, what I have now is I have 4 times 3. So the solution to this is going to be 12. All right, let's look at this one. This becomes log base 5 of 125 to the negative 1/2. Okay, so the radical tells me that it's a 1/2 power, and it's in the denominator, so that's why it's a negative. So if I use my log properties, I have negative 1/2 log 5 of 125. Okay, now I'm going to evaluate just this guy right here. So 5 to the what power equals 125? And that's going to be 3. So if I plug it back in here, this value of this is 3. So 5 cubed is 3, but I have to multiply it by negative 1/2, because that's what's out here in front. So the solution here is negative 3/2. All right, if we go to this one, again, I'm going to use my power property. So I'm going to bring the 2/3 out front, and then I have ln of E. And remember, ln E, this part of it is equal to 1 because they cancel each other out. So all of this reduces to just 2/3. Okay, last one. So ln of E to the negative 1/2. Square root in the denominator, it's negative. So power property, negative 1/2, ln to the E, and we know ln to the E is 1, so this whole thing is just 1/2. Okay, so now what we're going to do is we're going to take these long expressions and we're going to condense it. We're going to put it together so that we have just one logarithm. Now, here's what's going to happen. Remember up here we said we cannot use the distributive property. So when we look at this, this is one term. I can't separate it out. This is one term. I can't separate that out either. So what I'm going to be doing here is I want to look, I'm going to go back here to my properties. I have three things going on: addition, subtraction, and powers. And I'm going to look, in this case, I'm going to have the extended one and I'm going to try to consolidate it. All right. So what I have here, I'm just going to work left to right, is I know that I'm going to have an ln out front. All of these are ln's. So since they're all ln's, I'm going to have just one. And then what I have here is a plus b times a minus b. So I'm adding. When I add, I multiply. So I'm adding two different things. When I'm adding, I'm multiplying. Okay? Now, here I'm subtracting. When I'm subtracting, I'm dividing. So all of this is going to get divided by, I can't have a 2c. Remember, when I have this value that's out front, it's a power, so this is going to become c squared. So if I want to simplify this, really what I have is ln. Hopefully you see this as a perfect square. So if this is a perfect square, I'm going to have a squared minus b squared. If I was to FOIL this out, at this point you should be able to see that this is a perfect square, so it's a difference of squares over c squared. There's only one ln, and I have to have all of this in the parentheses. And I didn't actually write this very good. Probably should be all the way down here so that you see that this is all one ln. So here's my final answer. This is my condensed form. Okay? All right, so let me write this one. So I have this power up front. I'm going to rewrite it and say log of x plus 1 to the 1/2 power minus log of x squared plus log of x squared to the 1/2 power. Okay, so what I have here, and this is important, subtraction, this just tells me it's going to be in the denominator, and addition tells me that it's going to be up in the numerator. Okay, so if I write this, I'm going to have 1 log, and this is going to be up in the numerator, so I'm going to have x plus 1 to the 1/2 power. Now, if I have x squared times 1/2, all of this just simplifies to x. If I multiply this across, I would have 2 over 2, which is 1. So all of this is just multiplied by x. Now this is subtraction. This is in your denominator, so this is going to be x squared. Now I could go in and simplify it and do one more step here, so I would have log of x plus 1 to the 1/2 power, all over x. I could cross this x out with this x, and this is what I would have. Okay? All right, now what we're going to do is we're going to expand the expressions. We're going to make them longer. So if I look at this, I'm going to start, each one of these is going to have an ln. If we look back here, we have ln, ln, ln. So when we go the opposite direction, what we're doing is we're breaking this out, so we have to put our log or our natural log in front of everything. Okay, so I'm going to look at the x squared. So if I look at this x squared term, what I have here is ln of x squared. My y is in my numerator. I'm multiplying it together. So when we multiply, we add ln of y. And then the a term is in the denominator, so I'm going to subtract ln of the square root of a. And this would be my expanded form. Okay. If I look at this one, I have this power out here to the fifth, and if I want to expand this, it's like saying I'm going to take this 5 and plug it out here in front. So I would have 5 ln of x plus 5 ln of y. Now, I could also write this as ln x to the fifth plus ln y to the fifth, but if we want to fully expand that property, this is basically fully expanded. Now, same thing with that being said over here. I could take this and go one step farther and say 2 ln of x plus ln of y minus 1/2 ln of a. All right, so this is really what I have when it's fully extended. Okay? All right, so now what's going to happen is we know how we can condense it, or we know how we can expand it. So now we're going to use these properties to evaluate the expression. And all this means is that we're going to simplify. In some cases, we can simplify it down to a single number. In other cases, we're still going to have log. So if I look at this, I'm going to evaluate each part of this. So if I evaluate this, I can't say 2 to a power equals 6. If I go over here and I say 2 to the x equals 6, there's no base that's going to give me a 2. So I don't want to start that way. I'm going to start by putting everything together. So I have log base 2, and I'm multiplying. So I have 6 times 20, base 2, divided by 15. So if I do the math on this, I know that I can simplify this out. So 5 goes into this 3 times, it goes into this 4 times, this 3 goes into this 2 times, and so what I end up with is log base 2 of 8, right? Or you can say 120 divided by 15. And I didn't know that in my head. It was easier for me to do it the long way. Well, now, hopefully you see this. So if we popcorn this out, we have 2 to the x equals 8. How do I go from a base of 2 to 8? It's just 3. So all of this simplifies to just 3. All right, let's look at this one. So I'm going to do the same thing here. I want to use my power, so I'm going to get rid of this 100, because 16 to the 100 without a calculator, I have no idea what that's going to look like. So if I pull it out front, I have 100 log base 4 of 16. And I'm just working on this guy first. Okay? So if I do this, what value of my exponent is going to give me 16? It's going to be 4 squared, right? So 4 to the x equals 16, so x equals 2. So if this log simplifies to 2, I'm going to multiply this by 100. So this part of this becomes 200. Okay? So now here again, I can't do log, I can't do a base of 2 and ever get 6. So I'm going to use my exponent rules for these, or sorry, my log rules for these two. So I have log base 2 of 6 times 2/3. So I'm multiplying because this is addition. So if I do this, this whole thing simplifies to log base 2 of 4. Okay, so 2 squared gives me 4. So I'm adding. So if this whole thing here, this becomes a 2, so my answer here is going to be 202. So again, I simplified this out. And I kind of shortcutted this, but remember 2 to the x equals 4. So x has to equal 2, and that's what this is. Because I'm adding up here, I've simplified this out, and here's what I got. It equals 202. All right, lots of stuff in here with log rules. So come see me if you've got any questions.